I'll retape
We have a third one.
We have three. Might as well.
And we'll label that for whichever one it hits.
Yeah.
Whichever one you want to connect it to.
It's probably easier to work on the upper one.
We're the team representing the Puget Sound Electrical Apprenticeship Program for the IBEW Local 46. My name's Andrew Wissink, and I'm currently working on the Lincoln Square expansion in downtown Bellevue to 40-story towers going up. And I've also spent a lot of time working at Boeing facilities around the Puget Sound region.
My name is Xerxes Shelley, part of the Puget Sound Electrical Apprenticeship, sponsored by the International Brotherhood of Electrical Workers, Local 46, and I have been working around the Puget Sound area, a lot of experience in a variety of things. Motors, systems, distribution, and I also worked on the UW, University of Washington stadium expansion project, or remodel.
I am Matthew Polk. I am also a part of the apprenticeship here in my 5th year. I am a member of the Local 46 International Brotherhood of Electrical Workers. I currently am working on the Fluke Hall renovation at the University of Washington, and most of my experience has been in the industrial area of the electrical trade.
My name is Paul Valutsuk. I'm a 5th-year apprentice here at the JTC IBEW, and I'm working on a Red Hook Brewery restaurant project right now in Capitol Hill. Most of my experience has been in various types. I've been a residential journeyman for a couple of years, and then I joined the apprenticeship. I've done industrial and commercial and TI.
So, so what we need to talk about here is where we're at right now, where we got with the project, what our conclusions are. So I mean, to start with how it finished.
Yeah, well, we actually proved and validated that our system outputs what it's supposed to put out. We get 10 kW out of the system, and it generates fairly regularly. Everything was installed correctly, and there's no hot spots on anything. We checked and verified that actually with a thermal imager, which was really cool to actually see in action.
Yeah. I know Xerxes had a bunch of data and spreadsheets out and was actually able to show like some up to the efficiency that the building was using. We weren't able to get past that wall, obviously, without getting into power bills and stuff like that.
Correct. We were driving on. I was the spreadsheet looking at that, and looking at various data points, it was coming out to where it was exceeding the design specifications for the PV system.
Wow.
So that's awesome.
So the reason why we did this audit and commissioning, because in 2005 our school had a PV system that was installed, and it was advertised at 10 kW. So we wanted to install this power equipment and see if during the winter times we were getting what it was designed for and the parameters that it was designed in. And we did actually receive 10 kW during the winter from our east and west arrays.
Yeah.
So we saw points where we're getting almost to 12 on some of the really, really sunny days. Where, as you know, when we talked to Steve earlier, Steve was saying that that the ideal conditions actually would have been those sunny days where it was cooler, because hotter days mean that the PV arrays aren't as efficient. They run better on cooler days.
Yeah. And it was really actually interesting being able to check that and verify that with the temperature sensors that we had set up and monitoring that too.
Yeah. Well,
Definite correlation between the cooler temperatures and sunny days and the higher output. Another really interesting thing that I found out was when we got this meter in, the Fluke Connect 3-phase power monitor, the 3540, I had no idea that it was going to be so small and compact and that we could actually fit it inside of the panel, and it was completely parasitic in nature, so that way it drew all of its own power. You didn't have to plug it in. You could close everything up, and it would be able to safely monitor without having a dead front off or anything like that.
Yeah, and I really like the flexible current leads. They were really small and portable, and you can close up the dead front with them on.
With these leads, we actually had a easier time making sure we got these correct and installed in the proper direction. It has an arrow right on the top pointing the direction you need to go. I mean, it's simple. It takes all the science out of it. You know.
Well, yeah, what I really liked about these ones that were Fluke Connect and connected to the online based was that you can see it in real time that hey, something's wrong, versus these the older ones we had to download stuff, we had to actually show up and see hey, it's not recording properly.
Yeah,
And
not
after
only
a certain amount of time, the Fluke Connect app just threw us out a warning, hey, disconnected, something's wrong.
You can count on it to work when you need it to.
Yeah, and you got two places to get the data. You get the data on the system itself. You know, you can record it right there with a USB, or at the same time you're connected to the gateway and you're logging the stuff online to a server. I mean,
Exactly.
you get two different places you're getting the data, and you're getting the data to your phone wherever you need it. I mean, I know I logged in that thing probably the first week we had it. I think I logged in like every 2 hours, like, let me check this out. I've got something important.
The sun broke out. I need to see what's happening over here.
That truly is, I think, the best part of the whole deal is that we could all do that.
Yeah.
We could all see almost immediately what's going on, and we get notices on disconnects or some warnings, errors, whatever it may be, that we could all do it from our other locations, because we only got together once a week, once every 2 weeks. So
Yeah.
that worked really well.
With our
We could all
various
be
schedules.
together.
So we're getting ready to install these power quality meters on the AC side of our power arrays and of our photovoltaics arrays. Before we can install these, we needed to install an outlet because in this whole electrical room there was no 120 volt outlets, so we needed to install one for these units to operate.
We're getting ready to lock out and tag out the photovoltaic electric system in order to be able to install our hardwired power quality meters. All right, we have everything correctly installed, and we're going to go ahead, disconnect all of our lockout tagout equipment, fire everything up, and start recording data.
We are going to be downloading and analyzing the data that's coming off the older Fluke technology, the 434 Power Quality Analyzer. And right here we have the PV system interfacing with the utility feed. And we have passive CT meters on here that we have been using to monitor the power output of our solar array. And we are currently in the process of downloading our data off the older system, the non-connect. Okay, and I'm going to hook up the other one and get that one. As we disconnect the CT meters and everything off our live system, we're locking it out, the utility side, and we're going to lock out the solar side here in just a minute. I'm putting my lockout on here. It is safe.
So we're going to go through the setup of our Fluke condition monitoring equipment setup. It consists of a gateway right here, which we have already previously set up for this entire process. A 3-phase power meter, which we have right here. A two DC current sensors, 2 K-type temperature sensors, and 2 DC current sensors. So the first thing that we want to go over here real quick, since we've already set up our gateway, and we've previously set up our 2 K-type temperature sensors, we want to go over our 3-phase power meter, specifically the 3540 FC 3-phase power meter. This has its own Wi-Fi gateway in it, so it can operate independently from our gateway. Specifically, the advantage of this is that it has smaller, more flexible Rogowski coils, makes it much easier to install for long-term monitoring and closing the panel up, and all around is a safer feature. Also, the parasitic nature of the device allows us to connect it directly to the panel, so we don't run into a problem of having to install a 120 power source to run our monitoring session. Everything else will connect to the gateway. That includes the two K-type 3530 FC temperature sensors, the two 3511 FC DC voltage sensors, and the two 3521 FC DC current sensors.
They're on the disconnect and on the breaker, and we're going to put it in this lockbox.
Okay.
And we're going to put everything here because we would need a lot of trees and
Sure.
a lot
That
of
makes sense.
So we're going to put it in this lockbox.
Makes sense if we're all just gonna lock it.
Yes.
Yeah. So.
I think it was a two-phase approach, if you will. We were trying to use known technology that was quantifiable, that we knew in the real world was used. It was industry standard equipment in both the 434 and in our
Power quality logger.
Our power quality logger, yeah. Sorry. Using both of these things, we know that both of these pieces of equipment are used out in the real world by shops right now. And then trying to use this fairly new technology with the Connect stuff with the 3540 and its DC components that we had installed. We want to take that data and we want to take a system that we have, our PV system, where we're getting a constant level of power from. At any given day, we're getting power that we can measure from it, taking the design spec that we have and comparing all three of these different things and seeing if this is a feasible and cost-effective option for shops in the future.
When we came down to the brass tacks of actually installing the stuff, we ended up calculating that for having two people to install the older stuff, the 434 and the power quality logger, between having to install a receptacle, sending guys out to install it the first time, sending people out for a 2-week study to collect data every week, it would have come out to being 34 man hours for a journeyman electrician, which is quite substantial compared to the conditioning monitoring system that we installed, the 3540, and the DC system. Both of them put together would have taken a total of, probably was what, 16 hours?
Yeah, about 16 hours.
And I think a big thing to drive home is the cost saving of having used the condition monitoring equipment versus the older stuff is the Fluke Connect stuff, and it's easier to set up. It's faster to set up.
Yeah, you're gonna have to send out, for both of them, you're gonna have to send out two guys. You know, a journeyman and an apprentice. You're gonna bill for two journeymen. You know, you're gonna send them out. You need to have two guys there because you're disconnecting stuff. You're roping off area. You've got arc flash, stuff like that. You've got to worry about. So you're paying two guys to go out there. And if I'm putting my money on how much time I want to spend sending a guy back out there to have to go through all of that again to collect data, you know, I mean, I'm going with the 3540 all day. I don't need to send a guy back out there. It's installed. It's closed up in the panel. We're done.
Yeah, it's all
What I
right
just
there.
wanted to add is that this has no limitation as far as length of time that you can record with.
Yeah.
As in this one, you can only do 30 days, and this one is limited to,
Seven.
yes,
7
Yeah,
days.
that's
7
actually more of a
days.
spot
Yeah,
measurement
that-
tool
that's-
that we were
that's-
using. in a
yeah.
And the more
different
that you
capacity.
record, the more it compresses the data from this meter versus this one, since it sends everything to the cloud and everything's cloud-based, you can record as much as you want. It's just going to keep recording. You don't have to show up and download it and start it again.